These demos show a sampling of volume visualization and rendering techniques over a variety of scientific applications. The demos are running on Sun visualization workstations, ranging from a SPARCstation 470 with Sun Vision to a SPARCstation 370 powered by Sun's new visualization accelerators, the VX and the MVX. These accelerate Sun Vision's tools and libraries into image processing, volume rendering, photorealistic rendering, and 3D graphics. This is the bow shock of a stellar jet from a newly formed star. Blue represents a high-density contour showing the outline of the bow shock. Yellow and red are isosurfaces of sulfur and hydrogen emission intensities. The rendering, done by John Morse at the University of North Carolina, shows how the sulfur and hydrogen emissions are enveloped by the bow shock. Morse used several of Sun's visualization tools to study his data. He used the volume rendering tool in Sun Vision to create volume displays of the bow shock, the sulfur emissions, and the hydrogen emission separately. He extracted the surfaces from these volumes and combined them using Sun Vision's geometry viewing tool. The Sun Vision high-quality rendering tool did the final rendering of the frames. Morse used Sun Vision both on a SPARCstation desktop and on the accelerated SPARCstation VX plus MVX. A new volume rendering technique called splatting is shown here as it is running on the SPARCstation VX plus MVX. Splatting, developed by Lee Westover while at the University of North Carolina, uses a forward mapping technique. Here, the rendering of an RNA molecule is shown in the right window, and the finished result is shown in the left window. Westover used the C developers tools that come with the VX accelerator to port his algorithm to the SPARCstation VX plus MVX. This is a movie loop frames rendered with the splatting technique. This data is 96 CT scans of a head, each 256 by 256. The gradient strength at each voxel is used to isolate surfaces of skin and bone. By modifying the opacity of the skin, the underlying bone can be exposed. Each frame of the movie was rendered on a SPARCstation 370 VX plus MVX in 5 to 85 seconds. The images of this movie loop were rendered with Sun's volume rendering tool, SunVoxel, which uses a raycasting technique. The renderings are of a supercomputer simulation of the interaction of current flowing in two colliding cosmic strings, which are theorized to have been created during the Big Bang. Sun's volume rendering tool lets the user assign unique colors and opacity values to ranges of voxel values within the volume. This data is courtesy of Richard Matzner from the Center for Relativity at the University of Texas. The images of this movie loop were also rendered with Sun's volume rendering tool. Here, 61 MRI scans, each 256 by 256, were rendered using the raycasting technique. Volumetric editing was used to remove the skin and bone substances on one side of the head in order to reveal the structure of the brain surface underneath. This data is courtesy of Jeff Shaw from Vanderbilt University. Here, 400 slices from a seismic scan of an oil field have been rendered with the SunVoxel volume rendering tool. This movie loop is running with the Sun Vision movie tool on a SPARCstation 470. The user defined substances in the seismic volume based on ranges and velocity values. The user then assigned individual colors and opacity values to the substances. By setting the opacities to 0, the user can make various substances transparent so that areas of interest can be isolated. Sun's visualization products provide powerful yet easy-to-use environments for scientists and engineers. Visualization techniques such as volume rendering can be effectively used to reveal new information about complex data.